Now let's see question number 3. Question number 3, it is saying that how many super key possible for relational schema R with n attributes are A1, A2, A3 and An to An, and candidate keys A1, A2 and A3, A4. It is saying that it is given that a relational schema R with set of n attributes. A relational schema R with set of n attributes, and candidate keys are, there are two candidate keys. First candidate key is A1, A2 and second candidate key is A3, A4. See here, R is a relational schema with set of n attributes from A1, A2, A3 to An, and two candidate key. First candidate key is A1, A2 and second candidate key is A3, A4. And it is saying that how many super keys are possible. How many super keys are possible? Now see, we have seen two methods to find the number of super keys in a relational schema R with a given set of attributes and given set of candidate keys. Now see first method using set theory method. Now see this. Using set theory method, now see this. Suppose this is a set X, this is a set X and this is a set Y. This is a set Y. Now see, super key means set of attributes which can differentiate records uniquely. It may be minimal, it may not be minimal. Now and candidate key means minimal set of attributes which can differentiate records uniquely. So candidate key is A1, A2. Candidate key, suppose take first candidate key which is A1, A2. See, A1, A2 is a candidate key, means it is a minimal attribute set. A1, A2 is the minimal attribute set which can differentiate records uniquely, and A1, A2 is a candidate key. It consists of two attributes, so it is a compound candidate key. Now every candidate key is a super key. Every candidate key is a super key. So if we combine 0, if we combine 0 or more other attributes with the candidate key, we will get super keys. We will get super keys. See, this is the candidate key A1, A2. This is the candidate key A1, A2. A1, A2. This is the candidate key A1, A2. Now we will see the super keys, the number of super keys because of the candidate key A1, A2. The number of super keys because of the candidate key A1, A2 means A1, A2 itself is a super key because every candidate key is a super key. And now candidate key combines with 0 or more other attributes will form super key. Now 0 or more other attributes. See, when A1, A2 is a candidate key, the means how many attributes are there? Two attributes, A1, A2. What are the other attributes? What are the other attributes? Other attributes are after leaving A1, A2, other attributes are A3, A3, A4, comma, dot, 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 An. Other attributes are A3, A4, A5 to An. Other attributes are A3, A4, A5 to An. And A1, A2 we were not considering considering A1, A2 because A1, A2 are the attributes of the candidate key A1, A2. So other attributes are these attributes. When we will combine 0 or more other attributes, these are the other attributes, with this candidate key, we will get super key because of this candidate key. We will get super key because of this candidate key. Now means indirectly we can say that any subset of the other attributes, other attributes means A3, A4, A5 to AN. Any subset of the other attributes, these are the other attributes, means any subset of the other attributes, if we will combine candidate key A1, A2 with any subset of the other attributes, it will form super key. Means if we will combine candidate key A1, A2 with any subset of the other attribute, it will form super key. Means the number of super keys because of the candidate key A1, A2 is the number of subsets possible on the set of a set containing other attributes. Means the number of, I am repeating, the number of super keys possible over the candidate key A1, A2 is the number of subsets over a set containing other attributes. Other attributes means A3, A4 to AN. Now, how many subsets are possible of this set? This set contains n minus 2 elements. A3 to AN, this set contains n minus 2 elements. Now, how many subsets are possible of a set containing n minus 2 elements? Is 2 to the power, see here, is 2 to the power n minus 2. Understood? 2 to the power n minus 2. See, these many super keys are possible. 2 to the power n minus 2 super keys are possible because of the candidate key A1, A2, and this set X denotes the set of super keys over candidate key A1, A2 over candidate key A1, A2. Now see, because of the first candidate key, the number of super keys possible are this. And now see the number of super keys possible because of the candidate key A3, A4. Now see, candidate key is A3 and A4. And now what are the other attributes? The other attributes are A1, A2, A5 to AN. The other attributes are these. And now, how many subsets are possible on this set containing n minus 2 elements? Now see, this set is also containing n minus 2 elements. A3, A4, two attributes are candidate key, and remaining attributes are n minus 2. We are subtracting these two from the from these n elements, these n attributes. So how many elements are there? How many attributes are there? n minus 2. So how many subsets are possible of this set containing n minus 2 elements? 2 to the power So see here, Y is the set of super keys because of the candidate key A3, A4. Y is the set of super keys because of the candidate key A3, A3, A4. Now 2 to the power n minus 2 is the number of super keys. Is the number of super keys because of the candidate key A3, A4, and this set of super keys because of the candidate key A3, A4 we are denoting through Y. We are denoting through Y. Y is the set of super keys over candidate key A3, A4. Now there are only two super keys. There are only two candidate keys. So there are only two sets X and Y. Y is the set of super keys over candidate key A1, A2, and X is the set of super keys over candidate key A1, A2, and Y is the set of super keys over candidate key A3, A4. Now see this. See here A1, A2, A3, A4. See here A1, A2, A1, A2, A3, A4, and A1, A2, A3, A4, A5. Now see A1, A2, A3, A4 is a super key which belongs to the set X and which also belongs to the set Y. Why it is possible? See, A1, A2, A3, A4 contains the first candidate key. First candidate key is A1, A2. So A1, A2 is present here. So this is the super key which belongs to this set. And now this super key also belongs to this set. This super key also belongs to this set. Why it is also belonging to the set Y? Because it also contains the second candidate key. The second candidate key A3, A4. So, and see here, this is the super key which also belongs to this set, and it is also belonging to this set. It is belonging to set X because it contains the first candidate key A1, A2, and it is also containing the second candidate key A3, A4. So this is the super key which belongs to the set X and which belongs to the set Y. So these are the super keys, and many other super keys there are present which belongs to the set X and which belongs to the set Y. So if we are counting the number of super keys, we are also counting the repeated super keys, because these are the super keys. These types of super keys belongs to this set also and belongs to this set also. So when we will add these number of super keys and these number of super keys, this is not the correct answer, because there are repetitions. There are some super keys we are counting twice. There are some super keys like these two super keys we are counting twice. How we are counting twice? Once we are counting these type of super keys, I have shown only two examples. There are more other super keys possible which belongs to the set X as well as belongs to the set Y. So these are the super keys which belongs to the set X and which belongs to the set Y both. So when we will find the number of super keys possible because of these two candidate keys, if we will add this and this, then then the super keys which belongs to the set X and which belongs to the set Y are counted twice. We are counting these super keys two times. These super keys two times. These super keys are counted twice. So we have to subtract one time. We have to subtract one time the number of super keys which belongs to the set X and the number of super keys which belongs to the set X as well as set Y, means the super keys which are present in both set, that is the common super keys between the set and between the Y, we have to subtract these number of super keys once from the number of super keys present in X and the number of super keys present in Y, means the sum of super keys which are present in X and Y, after taking their sum we have to subtract one time the common super keys which are present in both X and Y, so that this will give the correct answer and there will not be repetition of super keys which belong to this set X and which belong to the set Y both. So how we will do this? See, this common reason indicates that the super keys which belongs to both set X and set Y, and now we have to count how many super keys are there, how many common super keys are there, means the super keys which belongs to the set X as well as belongs to the Y. This region represents the super keys which belong to the set X and which belongs to the set Y both. And now what type of super keys are these? These super keys which belongs to both the sets X and Y will contain both the candidate key. Both candidate key means the super keys which are common in both set will have both candidate key A1, A2 and A3, A4. See, these two super key belongs to the set X and belongs to the set Y. Both these two super keys are common super keys. So see here, these two super keys contain the candidate key A1, A2, also contain the candidate key A3, A4. This second super key also contains the candidate key A1, A2, also contains the candidate key A3, A4. Understood? So to find the number of super keys which belongs to the set X as well as belongs to the set Y, what we will do? We will do, see here, these super keys will contain both candidate key, means A1, A2, A3, A4, and both candidate keys this common super keys will contain. And what are the remaining? What are the other attributes? Other attributes are A5, A6, A7, AN. Means these attributes combined with 0 or more other attributes, then it will form the super keys. Means the super keys, the common super keys, means we have to find the number of sets possible of the set containing these many elements, these many attributes. How many attributes are there? See here, there are n minus 4 attributes. See, these are the 4 attributes. So we have to subtract 4 from the number of attributes. There are total n attributes. So there will be n minus 4 attributes. How many subsets are possible of a set containing n minus 4 elements? 2 to the power n minus 4. means 2 to the power n minus 4 elements, means 2 to the power n minus 4 super keys are there which are common between both the sets x and y. So these many super keys we have to subtract once to get the exact answer. If we will not subtract this, then the common super keys we are counting twice. So one time we are counting in x and other time we are counting in y. So we are counting twice. So to get the correct answer, we have to subtract it one time only. Understood? So that they will be counted only one time. We will get exact answer. So we will find those super keys which are common in both and we will subtract it from. Understood? So see here, what will be the answer? See here, this is the first method. This is the continuation of the first method. This is not the second method. Understood? This is the continuation of the first method. Understood? This is the how we will find the answer. See, the number of elements this is the n in x union y. The number of elements in x union y is equal to the number of elements in x plus the number of elements in y minus the number of elements in x intersection y. See here, then the number of elements in x is 2 to the power n minus 2 is equal to 2 to the power n minus 2. Now the number of elements in y is also 2 to the power n minus 2, then plus 2 to the power n minus 2. Now the number of elements in x intersection y, this is the region x intersection y. The number of elements in x intersection y is 2 to the power n minus 4. 2 to the power n minus 4 means minus 2 to the power n minus 4. Say 2 to the power n minus 4. Now we will take common 2 to the power n minus 4. Now what we will get here? Here we will get 2 to the power 2 plus, here we will also get 2 to the power 2. Now minus 2 to the power 0. Got it? Understood? Is equal to 2 to the power n minus 4 minus 1 is equal to 448 minus 1 7. 448 minus 1 7 means 7 into 2 to the power n minus 4. This is the answer. Answer means these many super keys are possible in a relational schema R with n attributes and two candidate keys A1, A2 and A3, A4. These many super keys are possible. Now see, this is the set theory method. We are solving it using this set theory method. Now we will see how we can solve it using second method, that is prime attributes method. Understood? Thank you.